So let's begin with this one. So when we're asked to perform an operation where we have several different operators, then we have to remember, please excuse my dear Aunt Sally. If you've never seen that, please excuse my dear Aunt Sally. This stands for parentheses, and that could mean any grouping symbols, exponents, multiply, divide, add, or subtract. Now, a quick little side note is that when multiplying and dividing are touching each other, they are of equal importance. So you go left to right. And the same thing with adding and subtracting. If they're side by side, you go left to right. So here we have adding and multiplying. So according to Aunt Sally, we multiply before we add. So 9 times 4 is 36. Bring down the 2. 2 plus 36 is, of course, 38. So that's how that simplifies. Let's look at this one. Again, if we consult Sally, we have multiplying and subtracting. So multiply comes before subtract. So we're going to do this operation right here. So remember, when we multiply fractions, we go straight across. Or if anything can reduce, we reduce. So the 5 on top and the 5 on bottom cancel, leaving 1 over 3. And then we bring down the other 1/3. Well, anything minus itself is just 0. If I have something and I take it away, then I don't have anything anymore. Here, this one has several more pieces to it. So if we go back to PEMDAS, then we have these absolute value symbols on top, and those are grouping symbols, and those work like parentheses. So inside that absolute value, we have to do what is on the inside. So 11 minus 6 is 5. And then I'm just going to copy everything else. And when we have a fraction like this, then we do all the stuff on top together, all the stuff on bottom, and then we look at reducing it. So the absolute value of 5 is 5. Bring the plus 7. On bottom, we have two operations. We have adding and multiplying, so we have to multiply first. So 2 times 3 is 6. So the top simplifies. 5 plus 7 is 12. And the bottom simplifies. 7 plus 6 is 13. That fraction doesn't reduce, so that is as far as we can go. Now let's look at one that's a little bit larger. So this looks a little intimidating because we have lots of numbers and signs and parentheses and brackets and symbols and all sorts of stuff. But if we go by our order of operation, then we can get there. And one of the biggest things is not to try to do too much at one time. So we have parentheses and we have brackets. All of this is in brackets. That's a grouping symbol. And then inside the brackets, we have those parentheses. So we work from inside out. Inside out. So on the inside, if we look at this part, what do we do first inside that parenthesis? Well, multiplying comes before subtracting. So 4 times 7 is 28. And then we're going to copy everything else just like it is. The minus 24, the 10 there, minus 30. All of that's in brackets. Then there's a 2 in front, and we're adding 5 out front. Now, inside the innermost parentheses, I'm going to copy the rest of it. 28 minus 24 is 4. And I'm going to copy everything else just like it was. So we simplified that parentheses. So inside the parentheses here, there's nothing left to do. So now we look inside the next grouping symbols, which are these brackets, and say, what do we do inside there first? Well, inside there we have multiplying and we have subtracting. So multiplying comes first. So 10 times 4 is 40. Bring down the minus 30 and copy everything else. So if we don't try to do too much in our head and don't try to skip too many steps, it's just taking one step after the other, and before it's over with, we'll be at the finish line. So on the inside, the only remaining operation inside the brackets is to subtract 40 minus 30, which is 10. Bring the 2 down and bring the 5 down. Now, we have to be careful here because we see the 5 plus 2, and that's one of those facts we memorize. 5 plus 2 is 7. But we can't do that because our operation with the 2 and the 10 is multiplying. Multiply before add. So 2 times 10 is 20. 5 plus 20 is 25. Nothing left to do. So we have made it to the end there. Another thing that this section has us to do is evaluate an expression. So when we evaluate an expression, we're plugging numbers in, and this is the formula, this is the expression that we have. XY means X times Y, and then we have plus Z. When you substitute into a formula, it's best to put the numbers in parentheses. There are times that the parentheses aren't necessary, but it's not always obvious before you begin. So in place of X, put a 4. In place of Y, put a 6. And in place of Z, put a 9. So we said X and Y are being multiplied. So which do we do first? Multiply or add? If we look at PEMDAS, we multiply first and then we add. So 4 times 6 plus 9. 24 plus 9. Well, 4 plus 9 is 13. Carry your 1. 1 plus 2 is 3. So we get 33. Now, I want to show you an example that you have to watch out for sometimes. I used this example or one like it in a previous class. And this is a type of problem that you'll see on the internet from time to time. I actually ran across one like this on YouTube. Sometimes you'll see it on Facebook, and different people will type in what the answer is, and there'll be thousands of responses, and some of the people say one answer, some say the other answer. And both groups will make an argument that's compelling for why their answer should be right, but there's only one right answer. So one group of people will say, aha, I don't have parentheses, I don't have exponents, but I have multiplying. So I have to multiply first. Well, that's not exactly true. Remember, with those two operations, if they are side by side, we go left to right. And this is where the mistake usually is. A lot of times people will just multiply first because of that M. But if multiplying or dividing are side by side like we have it, we have to go left to right. So 12 divided by 6 is 2. And then copy the rest. Then we multiply. 2 times 2 is 4. Bring down the plus 4, and we get 8. So that's what the correct answer is. Let's notice we would not get the same answer if we did it in the other way. So that's the correct answer. If we do it, that's green all of a sudden popped up. If we do the M before the D, like PEMDAS seems to indicate, 6 times 2 is 12. Copy everything else. 12 divided by 12 is 1. 1 plus 4 is 5. Well, that's not right because we don't do multiplying before dividing if they're side by side. If those operations are connected, we have to go left to right. All right. So the next problem is more about making a substitution. So they give us an equation, 4x plus 3 equals 9x minus 8. And they want us to see whether 3, or you could say x equals 3, is a solution. To be a solution, we're going to have one number on one side and the same number on the other side if we simplify. For things to be equal, they have to be the same amount. So they're not wanting us to solve this and get x by itself. They just want us to check by plugging in 3 where x goes and seeing if this side and this side really are equal. So where we have an x, we're going to try a 3 and see if this works. So everywhere there's an x, put a 3 in. Now they're just randomly giving us a number. They're not telling us where the 3 comes from. They just want us to practice plugging numbers into a formula. So 4 times 3 plus 3, 9 times 3 minus 8. So order of operation, let's do the left side of the equation first, and then we'll do the right side. So on the left side, we multiply first. 4 times 3 is 12. 12 plus 3 is 15. On the other side, we multiply before we subtract. 9 times 3 is 27. 27 minus 8 is 19. And those are not equal. So that tells us that 3 is not a solution. 3 does not make the equation work. Okay, they ask us to make a translation. They give us a statement, and they want us to write this into an equation or algebra using symbols. So the sum means add, of 6 and a number. We don't know what that number is, so we're going to use x for that number. So 6 plus x, the sum of 6 and x, so 6 plus x means equal 18. If it says difference, difference is subtract. Product is multiply. Quotient is divide. So it's just interpreting what do these words mean, how do we translate them into symbols.